your lesson. So first thing I need you to do is actually change, that's supposed to be a 10, it's a 5. In your note packet, change those two things to 10s. Alright, so basically today is about factoring trinomials, which is something you've done for a long time. So you have taken something and actually we did this one yesterday and we factored it. And you factored it and you're like, okay, what adds up to 6? What adds up to 5? What multiplies to 6? And you told me that was 2 and 3. So we factored it to that and we were done. So today is nothing really new, it's just a little bit of an extension. And so that extension comes from what's on the right over here. I have degree 4, I have degree 6, I could have degree 10. What you have to look out for is whatever your lead degree is, so if I have degree 20, my degree in the middle has to be half of that. So if that's the case, you can factor it like a trinomial, if the numbers allow. So, like, I could change this to 20, and then I would change this to 10. I could change that 4 to 30, and I would change that 2 to 15, and then we could factor it. I could change this to 100, and then half of 100 is 50. So it doesn't really matter how big the degree is if you have a trinomial. It just matters that your first term is whatever it is, and it has to be even, and then your next term is half of that, and then you have a constant. If that's what you have, you can factor them. And so describe the conditions under which you can apply this method. We have these 3 kind of stipulations. So first, the first term must be an even power. Kind of stated that. The second term needs to be half of the first term. Pointed that out a few different ways. And then our third is a constant. So what I would really focus on is these 2 things. And you can shorten that up if you want. But the constant piece kind of stands out because if you take a greatest common factor, you might end up with a constant. If you don't take a greatest common factor, then you might just be stuck. So go ahead, get that down, and then we are going to factor some lovely problems. Looks like we're good. You good? Do you need more time? If you need more time, I'm happy to wait. See a couple people writing, so I'll just wait. All right. So, first problem. We're going to start factoring. The joys of not an easy one. So here we go to start. So I'm going to put 2 parentheses up. But what's the first thing you always look for when you factor? Not a perfect square. Greatest common factor. Does this have a greatest common factor? No. So then I go, okay, what are my options? Difference of perfect squares is a great thing to think about, but I have 3 terms. I don't have 2, so I'm going to jump past that. And then I go to this. So it's a trinomial, so I'm going to factor it like a trinomial. I see that I have 4, and then I have 2. So the first term is even, the next term is half of that, so that's good. And now I'm going to start. What numbers multiply to 3? 1 and 3. So I'm going to put them down. I like to put the 3 first and then the 1 to follow. Then what I want you to realize is I'm going to point to this problem really quick. So half of 2 is 1, and notice when I go to this, 1 times, or I should say 1x times 1x gives me that x squared. So I really just take what's in the middle and I put that in the front. So this is going to be 3x squared and 1x squared. And if you think about that, when I distribute, that actually gives me the 3x to the 4th. So that's why it works that way. And I'm actually going to, I'll put that down here because we are going to check these. So next, I look at 8. What numbers multiply to 8? Let's list them.
2 and 4.
2 and 4. What else? 1 and 8. Anything else? No, that's it. Now, this is a minus. So what does that mean in terms of my signs? What kind of signs do I have? Have what? Negative and a positive. Good. So I'm off to the side going to put a plus and a minus. Because I'm going to drop them in at some point. I don't know what it's going to be, but I do have to put that down. So now we guess and check. What do we want to guess? We have to get 2. So 2 and 4 is a safe option. Do I want to put them as 2, 4, or should I do 4, 2? 2, 4. We're trying. So I put 2, 4. And anyone have a strong opinion on the signs? All right, we're just dropping them in. I'm going to put plus, minus. And the signs don't matter that much because if I get the correct number but the wrong sign, I flip my signs and I got it to work. So I'm going to finish distributing here. So I go 3x squared times negative 4 and I get negative 12x squared. Then I come here and I get 2x squared. And then I multiply the last and I get negative 8. This is good and this is good. Am I going to get positive 2 from negative 12 and 2? No. So that's wrong. So I'm going to flip them. I'm going to take this 2 and this 4 and change them. So I got 4 here and 2 here. If I multiply 3x squared by 1x squared, does it change my first answer? No. And if I go 4 times 2 instead of 2 times 4, I still get the negative 8. So instead, I'm just going to work in these middle pieces. So I'm going to go 3x squared, so my first times my last, and I get negative 6x squared. And then I do my middle, so I go 4 times x squared, and I get plus, 4x squared. That gives me negative 2x squared. What does that tell me? It should flip my signs. If I flip my signs, I have it. So I'm going to erase my signs and change those. So now if I go negative 4 times x squared, that gives me negative 4x squared. If I go 3x squared times 2, that gives me positive 6x, which gives me positive 2x, which now gives me everything that I wanted. And so that is factored. That's the factored form. So it's guess and check, so it takes a little bit of practice. Questions? All right, next one. Oh boy. All right, so I look, do I have a greatest common factor I can take out? No. So then I'm gonna look at my powers. I got 4 and I got 2, so that's good. So I'm gonna draw my parentheses so I can start this. Let's list off some numbers for 18.
3 and 6.
3 and 6. What are my other factors of 18?
2 and 9.
1 and 18. Anything else? 16.
Oh.
You're good. I like it though. That's what we gotta do. We gotta just keep throwing numbers out, see what happens. So that's where we're looking. And anything else? Nope, that's gonna be it. Let's talk about 6. 6, let's list our numbers. What are our factors? 1 and 6, 2 and 3. All right, I need to get negative 23 in there. So when I look at that, I'm thinking negative 23. I'm probably not using 1 and 18 because that's probably going to give me a really big number. Okay. Now the 2 and the 9 could give me a big number depending how I use the 2 and the 3 or the 1 and the 6. So there's an option there. And then the 3 and the 6, and then those things also could work. So now we just choose and we start working. Does anyone have a gut feeling about one of the numbers?
3 and 6 and 2 and
3 and 6 and 2 and 3. All right, should I write them just like that? 3, 6. And then 2 and 3. So we're going to try this. It's a minus sign, so that tells me I have a plus and a minus. That comes from right there. And it tells me that the bigger number needs to be negative. Okay? So when I think about this, 6 times 2 is going to be bigger than 3 times 3, correct? Yeah, so I'm going to put the minus by the 2 so it affects that piece. Then I put a plus. So we were purposeful about the numbers we chose to start. So I'm not even going to distribute the whole thing. I'm only going to distribute the first and the last and the 2 middle. That's my check. So I do my check quick. I get 9x squared, negative 12x squared. Is that giving me negative 23x squared? No. New combination. Does it pay to switch the 3 and the 2? No, because we tried to get the biggest number we could and we didn't get a number big enough. So what should we do next?
switch the 6 and the 3.
If we switch the 6 and the 3, it would just give us a smaller combination. Okay, so what else could we do?
It's 2 and 9.
2 and 9? Alright, so I'm going to get rid of the first ones and I'm just going to try this. Do you want to keep the 2 and the 3?
Do 6 and
Okay. Or did you want that flipped? We're going to go with this. So I'm going to put a plus and a minus. Again, my signs don't matter a ton. Thank you very much. So our goal is to just check it quick now. So check my first and my last and my 2 middle. And I get not that. Too much. Okay? So too much. Whew. Let's try the other combination. Let's try a 2 and a 3. Multiply them out. So 9 times 3 gives me negative . Try it without a calculator. Negative 27 x squared. Multiply the 2's together. You get a plus 4x squared. Does that work? It does work. I do end up with negative 23x squared. And then I can really quickly check and say, well, 9x squared times 2x is 18x to the 4th. That's good. And then I can also do the end of that and go 2 times negative 3 and get negative 6. We got it to match. That's our answer. Questions? When you are factoring, don't erase these things. Okay? Like if you do something that's wrong, leave it there. Because what you'll find is you start noticing patterns or things as you're going, and then it might help you actually get to the answer quicker. Okay? Alright. Last one right here. No greatest common factor, so I'm going to put my parentheses. I want you to list the factors of 15, and I want you to list the factors of 8. Write them off on the side, and then I'll write them off on the side. I want you to also write your signs down. So it's a plus sign. So what are my signs? So they're going to be plus plus because of the positive 8, but realize that when it's positive, it could be either plus plus or minus minus. So this plus sign for the 26 tells me that it has to be a plus plus. Okay? Anyone have some numbers they think might work?
Three and five.
3 and 5. So this is 5x to the 5th this time, and this is 3x to the 5th. So notice the 10 and the 5, but we just take half of 10, that's what we got. What should we multiply by? 1 and 8 or 2 and 4? So this is where you start going kind of mad as a mathematician, because you just start talking. You go, well, 5 times 2 is 10, and 3 times 4 is 12. Does that give me 26? No. 5 times 4 is 20, and then 2 times 3 is, does that add up to 26? It does. So then I just have to make that happen. So I have to go. So what we did is we just guessed and checked out loud instead of on the paper. So I said 4 times 5, so I need to put the 4 there and the 2 there. And then as practice, we're going to actually distribute this out, just so we get used to it and we see it one more time. So I'm going to distribute the whole way. So nice and easy, that gives me the 15x to the 10th. Go to the next, that gives me 20x to the 5th. Then I have a 6x to the 5th. And I have an 8. Combining those like terms. Checks out. There's our solution. Questions? All right, if you're good, flip the page. Okay, the next thing that we're going to look at is factoring trinomials again. And what I need you to realize here is you do not have to memorize this. Okay? If you see this pattern and it works for you, great, use it. If it doesn't work for you, just factor it like a normal trinomial. It doesn't actually, I mean, once you get really good at factoring the trinomials, it doesn't actually take that much more time. So what I want you to realize though is that when you come across numbers, or I should say standard form that looks like this, we factor them very quickly because there's a pattern that's going on. And so we're going to dive in on the first one and just see what that pattern becomes. But so you can see that on every single factor on your paper, Below it, it has a middle term that is 3 times x. It has 3 times x there on that one too. It has 6 times x times 2, and then it has 20 times x squared times 2. And the times 2 is always something that is going to be there. It's always something that's happening whenever you have perfect squares that are added together, all right, or subtracted from each other. So we're going to just see how that plays out. And I'm not even going to have you write any of this down, except for if you would like to write down these two things, you can write that down and we will use it on the next 4 problems. So it's going to get you more used to the A's and B's and the generic forms, just like we did with perfect squares, the difference. All right, so for these problems, we're just going to utilize these things really quickly. And again, if you don't like using them, you don't have to. You can always just factor like a trinomial. That's fine. This is just meant to give you a little bit of a time saver, okay? So, does anyone need this a little bit longer? I see 2 people going, so I'll just wait. So, first one. What I really look for when I'm looking at this is I look for perfect squares. So I have a perfect square right there. I have a perfect square right there. So that is kind of making me think, you know, I'm either adding or subtracting these. Then I look at my sign, and I got a minus sign there. So that's telling me, okay, well then I'm doing subtraction both times, because a negative times a negative is positive. So honestly, when I see this, I just go like this and say, okay, square root of that is x squared. Square root of 4, or of 16 is 4. And I write that down twice. And I put my minus signs in. That's factored. That's done. Now, the thing to check is this middle piece. So this negative 8x squared, this confirms that I did this right. So if I take negative 4 times x squared, I get negative 4x squared. And the pattern always says that I just take that and times it by 2. And that gives me negative 8x squared. And so that checks out exactly with what we just had. And so that's factored. Am I done factoring that though? Why would I not be done factoring that? I can simplify more. So we just looked at perfect trinomial squares, but this does factor more. I have the difference of perfect squares here. So I actually can write this as x plus 2 times x minus 2 times x plus 2 times x minus 2, because it does factor down further than that. So that would be factored completely. That would not be the perfect square trinomial though. So that's what it factors to. All right. Is 9 a perfect square? Is 25 a perfect square? So then I can take 3x plus 5 times 3x plus 5, and I think I just factored it. But I'm going to check it really quick. What's 3 times 5? X. 15x. And then I have to times that by 2, which is 30x, which is right there. So that's done. Can I factor that anymore? No, that one's done. Can't do anything else with that. So just to kind of show how this works. So this is a squared plus 2ab plus b squared, and that factors to, in this case, a plus b times a plus b. So that's where your formula shows up. That's what's going on. All right, let's just take a look at 3 or 4. Your choice. Which one do we want to do? Neither is not an option. 3. All right. So I have a perfect square. I have a perfect square. Square root of this, 2x squared. Square root of 49, 7. What sign should I put in there? It's going to be negatives. So keep going for it. So we got negatives there. And so we got negatives there. And when I look at this, I just multiply them together. So that gives me negative 14x squared. And then I take that and I double it, which gives me that. So that's my check to make sure it was all right. But it worked. Okay? So that is it. Again, you can use the pattern. You don't have to. You can just factor like a normal trinomial. Okay? I use the pattern, but it's really your choice. If it's something you're like, I have to memorize this, don't memorize it. Okay? Just focus on the factor. All right? Get that other sheet of paper out now. We are going to factor that completely. And by we, I mean you. And I'm only going to give you 1 minute to do it, because it doesn't take more than a minute. So, your minute starts right now. What?
Feels like a game show.
Kind of is like a game show. Time's up. So, this is what it factors to. So, difference of perfect squares, x squared minus 4, x squared plus 4. Then, next thing I do, difference of perfect squares, x plus 2, x minus 2. Can't do anything there. X squared plus 4. That is factored completely. We're done. Okay? So, kind of tricky, not super tricky though. Alright? Now we're going to do one other thing. We're going to solve it. So, you already factored it, so I'm not going to make you factor it again. But, we give you a problem like this every year. And every year, people do this. I don't know how a square root and a fourth root cancel out, but it does on your test apparently. So don't write this down. Don't write that down. And then I get x equals plus or minus 4. How many solutions is that? 2. How many solutions do I have? In total, how many should I have? 4. Yeah. There should be a big alarm bell going off in your head like, this is not right. All right, so that's not right. So when we say solve, the first thing we always need to think is you hear solve, you think factor. If I can factor something, I factor it. I can factor this. We just did. It factors to that x plus 2, x minus 2, and then x squared plus 4. So I'm solving it equals 0. I keep it like that. So I'm going to start from here. 2 of my solutions are really easy to see. What are 2 of my solutions?
X equals 2, x equals negative 2.
Perfect. So some people like to write it like that. I like to write it like this. I always have a few people that like x equals plus or minus 2. I don't care which way. They both are the same thing. I'm just going to keep going with this. Now this, x squared plus 4, I set it equal to 0. Just like I truly set these other pieces equal to 0 as well. And then I solve. So I minus 4. What's the square root of negative 4? 2i, but it's more. Plus or minus. So I take the square root here, and that does give me x equals plus or minus 2i. I do write my imaginaries pretty much always with a plus or minus sign because they come in pairs. So it's expected that you would kind of do that, all right? But I don't take anything off if you write x equals 2i and then x equals negative 2i. That's fine. That's your choice. Questions? All right, so you have a mod now to get started on this homework.